Okay, this lesson is Unit 1, Lesson 4. We are talking about even and odd functions. And I started off the lesson by reviewing what we did at the end of Unit 3, or Lesson 3, excuse me. Okay, and we had several different graphs that we had plotted a bunch of points, or plugged in a bunch of numbers, got the points and plotted them and connected them and saw the transformations that we had on graphs. So what I'm going to talk about today is summarizing the transformations that we saw. So, to begin with, I summarize those by saying, remember that x and y. And what we're talking about, just to give you a little preview, an idea, f of x was equal to x squared. That's what we saw. And then we had one that was f of x was equal to x squared plus 3. And we had one that was f of x equals x minus 2 quantity squared. So, take that away. So what we were noticing, and people were able to tell me that this 3 right here, okay, they remember, let me change my color. They remembered that this 3 made the graph go up, shifted it up, and this 2 shifted it to the right. And so that prompted our discussion and let us know the difference between the 3 and the 2 is the 3 is outside the parentheses of our function, and the 2 is inside the parentheses. And then we talked about how it was plus 3 and it went up. And so when it's going up and it's affecting that y value, it goes in the same direction that you think it's going to do. But if it affects the x coordinate, the 2 here, minus 2, everybody would think we would go to the left, but we actually go to the right, so we do the opposite of what we think. We already know that x describes the horizontal motion, and y describes the vertical motion. All right, I'm going to pause for 1 second. Then we also had those functions that we had f of x was equal to negative x squared, and f of x was equal to negative x squared. Oops, inside. Okay, so again, the negative sign has a special effect on a graph, and when you have a negative sign, we talked about that they're going to flip over an axis. And if the negative is outside, this is outside the parentheses, this one's inside. If the negative is outside, it affects the y value. It does, and so it's going to, if it affects the y value, it's going to flip it over the x-axis. That means that if the negative's on the inside, it's going to affect the x coordinate, and that is going to flip over the y-axis, and you'll see that as we go along. We're going to work on that a lot today. So those are the effects of the numbers, okay? The other number that we talked about was f of x was equal to 3x squared, okay? And so I'm pointing this out because these two numbers, this is adding, this is subtracting, but this is multiplication. So the operation has an effect. If it is plus or minus, then we have what is known as a shift. And if it is multiplication or division, then we have what we talked about, a stretch or a compression. And that was all determined on that a value, okay? Most of the stretches or compressions that all the ones we talked about were a vertical stretch and a vertical compression. And a stretch was if it was greater than 1. Think about pulling your head way up and making yourself real skinny. If it's less than 1, it's a compression, and that's when you push it down, and that makes everything wider. Okay? So, these rules are going to be helpful as we go through on Lesson 4. These are the directions of what you have to do, and these are all the functions. And what I did is I went ahead and made some graphs for you to make it easier for you to follow the directions. So, the first direction says, graph the parent function, sketch the parent function and the original function. And this right here is the original function that we're dealing with, okay? Now, my parent function, let me go back to my pen. Okay, parent function. When you look at this, you're looking at your graph, and if you have any trouble with this, you need to come see me, and I'll do it with you with your parent function packet right next to you. But you look at this, and this looks most closely like y equals x. That is a graph on our parent function packet. It is the linear function, okay? And we are going to graph that. What it looks like, it is a line going through the middle, something like that, okay? And then we have to go identify what, excuse me, we have to go identify what does this 2 do to the graph. And it's multiplying, so that means it's a stretch, and everything that we've talked about has been vertical. So we have a vertical stretch. And a vertical stretch on the line is what happens when you actually increase the slope. So we have this 0, 0 starting point, and instead of going up 1 over 1 that we do on our parent function, we would go up 2 and over 1. So I hope you can see that that means that we are going to have a much steeper line. So it would look something like this. Okay? It's a sketch, doesn't have to be exact. So that's what part A is asking you to do. Okay? Part B says check it on your graphing calculator. Well, I got it checked, so we're good to go. Part C says give the domain and range. So the domain of this function of every line is negative infinity to positive infinity. It goes on forever and ever in both directions, left and right. And the range is the same, negative infinity to positive infinity. Okay, and this last one we can't answer yet until we do our graphs. Okay, so according to that chart we just talked about, we have to graph f of negative x. And when you do f of negative x, you're working not with the parent function, you're talking about this original function, or y equals 2x. Okay, but this negative sign is inside, and inside affects the x, and that means it's going to flip over the y. And this, the negative, is on the outside, so it affects the y, and that means I'm going to flip it over the x. So actually what we did is we went and put a y here and an x here, and that lets us remember which one we're going to flip over. So when you have 0, 0, it's on the y-axis. So I flip it over the y-axis, it doesn't move. But I go up to this point, and to flip it over the y-axis, I see how far it is from the y-axis and go in the same distance the other direction. So that's going to put me about right there. And then I go down to the bottom, again, go to the y-axis in the same direction in the other way. And it's going to give me something of this sort. So when I draw that, it's going to look something like this. So that's f of negative x. That's taking this pink line and flipping it over the y-axis. Now let's go flip it over the x-axis. So if I flip it over the x-axis, again, my 0, 0 point is going to stay the same. But this point up here is going to go over the x. So that distance is going to be that distance down here. And then this one goes up to the x-axis and flips up. So it's looking like this. And let's see what my line looks like. I think I change this and do this every time. It can be annoying. And so we're looking like that. Okay, so that's, we graphed them both. And I hope you can see that we have 1, 2, 3 different graphs. Okay, and we have to determine whether this function has symmetry, or it's an odd function or an even function, what kind of symmetry it has. And I don't have room to write on this page, so I went back here to say I'm looking at, oh poo, I'm on the line. Let me get to my pen. Okay, so I go back here, and f of negative x is either equal to f of x, or f of negative x is equal to negative f of x. Now that's what it looks like algebraically, but according to our graphs, this was the graph that's in box 2. And f of x is the graph that's in box 1. Negative f of x is what's in box 3. So we're looking at the graph of 2. If it is like number 1, then we have an even function. If it is like number 2, then we have an odd function. So if I go back to my functions and I look, and here's number 2, does number 2 look like number 1? Hope you all said no. So it's not an even function. Does number 2 look like number 3? And it does, and since it does, then we have an odd function, or the symmetry of this function is what we call odd. Okay? Moving on to number 2. Find the parent function again. Okay, it is linear again. It has none of the other extra parts that any of our other parent functions have, so it's y equals x. And so we're going to go draw that parent function, and this is why I have you draw it in pen, because this is the one you shouldn't make a mistake on, because you've got the graph right there in your little chart. So that's y equals x. And now we have to talk about what kind of changes. Actually, I'm going to change and go to this one. All right, what kind of changes? And we have a plus 5 and a minus 2, which everybody was able to tell me that that's minus 5 minus 2. And so my 0, 0 point has been shifted to the left 5 units and down 2 units to right here. And what I told y'all is when you're looking, when you graph this and find it, look up at the one above it. It's very similar. It's exactly like the one above it, but it's been shifted. So it will have this same steepness, or what we refer to as slope. Oh, it stayed that time. All right, and so I'm going to try to make it look like that one, same type of slope. So that's what we have. And now we're going to go name our domain and range. So my domain is, it's a line, negative infinity to positive infinity. My range, again, negative infinity to positive infinity. Okay, and now this one we flip over the y, this one we're flipping over the x. Okay. And so you need that original point, negative 5, 2. And if I flip it over the y, everybody was able to tell me that means I'm going to go over here to 5. I'm still down at negative 2. And you got to figure out which way the line goes. So take this point and you flip it over. And that means I'm close to that axis. And that means it'll go this way because this one is further away. So I went further away. So let's go draw that line. And something like that. Actually, he's a little off. Let's see if I can fix him. That's a little better. Okay, so you got the idea. Now we need to go draw the other one. Let's go figure out where that point went. So if I'm flipping it over the x-axis, this is my x, so that means it's going to go up here. So I'm going to stay at negative 5, but instead I'm going to go up to positive 2. So it's going to go here. That's flipping it over the x-axis. And this point will go down here. So that point moved to down here. And this point, of course, is going up, which is putting it up here. So I'm going to go sketch that line. Let's see if that gives, yeah, boom. So we have it. And I have my 2 lines. So I'm looking back, and to determine the symmetry, does this number 2 match number 1? It does not, so it's not even. Does number 2 match number 3? It does not, so it's not odd, and we say that it's neither. Okay, number 3. All right, so this one's a little different. Our parent function, all right, looking at it, it has a 2 on it. So that means our parent function is the quadratic, which is y equals x squared. We have that key point that you want to know about, which is 0, 0. And it's a sketch, so that's what we got. Our domain is negative infinity to positive infinity. Our range changes because the lowest point on my graph is 0, and the highest point is infinity. Okay? My bad. You know what I didn't do, y'all? I forgot to graph the change. Let's go graph that change. I was doing the parent function. Okay, so we graphed the parent function. Now I have to talk about these changes. Okay, -2, we've talked about before, is a vertical stretch. Now, how does that show up in a parabola? That doesn't spell stretch. It actually makes it skinnier. It goes up faster. And the negative is going to flip it. That's outside. Outside affects the y, so it's going to flip over x. So when I do the 2, I'm going to have a skinnier parabola, and then the flip over the x is going to make it down. So this 0, 0 point stays the same. So you draw your parabola down, but make sure that it's skinnier than whatever you drew for your parent function. Now, my domain is still -infinity to infinity. My range, however, the lowest point that I have here is -infinity, and the highest point is 0. Okay? We're flipping over the y. We're flipping over the x. So if I flip this over the y, my 0, 0 point doesn't change. And we've talked a lot. When I flip this, this point's going to go over there because it's symmetric. So it will look the same. So make it skinny and look the same as what you have. But when I flip it over the x, that means this point is going up here. I still have 0, 0, but my skinny parabola is now going up instead of down. So, testing for my symmetry. Does number 2 look like number 1? Yes, it does. And so our answer is it is even. Okay? I did have someone ask me if 2 would ever equal 3, and that answer would be no. All right, one last one I'm going to try to do real quick. What is my parent function again here? It is y equals x squared. So I have my 0, 0, and I have my parabola. All right, and so then when you're looking at, let's go, the difference, this is what I'm telling you to look up here. The only difference in what we just did and this one is the +1, which everybody knew it moved up 1. So my 0, 0 point is now at 1, 0, and then I have that skinny parabola from there. So what's my domain? Still -infinity to infinity. What's my range? The lowest point is -infinity, but the highest point is now 1. Can't do the symmetry yet. We got to go over the y and over the x. So when I flip it over the y, that point is going to stay the same because it's on the y-axis. So I'm going to have my same skinny parabola going down. But this is where people get messed up. When I take that point and I flip it over the x-axis, I don't just go up from here. I have to take that point down here. And so now it is at 0, -1, and then it flips like that. It will end up looking like that. So, does the graph of 1 equal the graph of 2? It does. So once again, we have an even function. So there are 4 examples, and you have one of each possibility that you could have. If you have any questions, please come see me or email me. Thank you.